Right, morning. Right, so today we're going to quickly take a look at coordinate geometry. In order to do coordinate geometry, we have to remember these small formulae, right? Right, for those who don't want, remember, you can print the summary and have it, right? Right, so you can print the summary so you have it close to you to work with. Right, so first thing we need to be able to do is to find the distance between 2 points and your formula there. Midpoint, formula there. Gradient, formula there. Okay, so once you have 2 points, you should be able to find any of these things. Right, one thing I want to talk about now with gradient. Remember, gradient gives you an idea of how the line is sloped. So for you to find the gradient, y2 minus y1. Oh, this thing happened again. y2 minus y1 over x2 minus x1, right? Right. So if you look at it, your gradient here, I want you to remember a few things. That if you have a line slope like that, that's a positive gradient. If you have a line slope like this, that is a negative gradient. If you have a line slope like this, that's a what? No gradient, right? Gradient is 0, right? But let me see if I remember what we did yesterday. We did yesterday. Wrong class or lesson, sorry. We didn't do join lines yesterday. Sorry, I lesson. Right, that line has no gradient, and this line has a gradient of how much? This one is 0. This one is negative. This one is positive. This one is 1? Nah, infinity. Right? That gradient is infinity. Right? We need to remember a few things about gradients. Parallel lines. If I gave you 2 parallel lines, they have the same gradient. Okay? Parallel lines have equal gradients. Of the physics exam here. Right? 2 parallel lines. Right? If you have parallel lines, the gradients equal. Perpendicular lines, when you multiply their gradients, you're going to get -1. So the product of their gradients is -1. That's okay? All right. So what's a quick way to work out the gradient of something perpendicular? So if I gave you a line, right? And I said that the gradient of that line is 2/3. And I asked, what is the gradient of the perpendicular line to that? What would it be? Right? Flip the value over and change the sign. So flip the value over, you'll get 3 and 2 and change the sign. Okay? That is called your negative reciprocal. Okay? So perpendicular lines, they are negative reciprocals of each other. Right, Sama? Right? So just remember those things, right? Parallel lines, equal gradients. Perpendicular lines, their product is -1, or they are negative reciprocals of each other. Okay, next. The next thing we need to be able to remember is how to find the equation of a line, right? What I did here for you is I gave you the equation of a line, and I also told you how to find the equation of the line, right? Equation of a line is y is mx plus c. Every line looks like that. Every straight line looks like that. How do you find the equation of a line? Number 1, find gradient. Number 2, obtain a point on the line. And number 3, substitute the point and the gradient. Okay, and find the C. Right, so let's just do one as a quick example before we go into some past papers, right? 2, 3, and 4, 6. Right? Let's find the gradient first. So I want to find the equation of the line passing through 2, 3, and 4, 6. All right? First thing, find gradient. Y2 minus Y1, which is 6 minus 3, all over X2 minus X1. So that's 3 on 2. Right? So I have the gradient, and now I can pick any one of these. So I have the gradient, and it's step 1, right? And it's step 1 upon the gradient. So the gradient is 3 on 2. Point on the line, I can choose any point. I will choose 2, 3. And now I'm going to substitute into this formula to find C. C is Y minus the gradient by the X value. 2 will cancel, and I will get the Y-intercept to be 0. So the final answer is Y is equal to 3 on 2X plus 0. You all see that? So I've taken 2 points, I found the gradient. I use the gradient formula, right? And after the gradient, I use any point. You could use 2, 3, or you could use 4, 6. It don't matter. Anyone could work. Right? And I found the Y-intercept, right, Faith? And after the Y-intercept, I plugged it back into the equation. I want you to notice, once the value in front of Y is 1, the coefficients of 1, whatever in front of X, that will be your gradient. For example, what's the gradient here? What's the gradient there? The gradient is for whatever in front of X, coefficients of X. So the gradient is 3. Y-intercept is minus 2, right? Suppose on the other hand, I gave you something like this. 2y is equal to 4x minus 6. What's the gradient? You have to divide by 2 first, because the value in front of y must be what? Must be 1, right? So divide by 2 and you'll get 2x minus 3. So it means that the gradient is 2. Last one. Suppose I said 3y minus 6x plus 6x is 9. What you'll do here? Right? Divide by 3, but it has to be in the form what? Y is mx plus c, right? So carry across the x first, you'll get minus 6x plus 9, and then divide by 3. You'll get y is minus 2x plus 3. Everybody okay with that? So you have to remember those little things, right? All right, good. So that is your equation of a line. All right. These are your rules here for quadratics as well. All right, we can squeeze in 1 or 2 of those later on, right? In fact, let's just walk it through one time. Well, I might see in the back. Right, so first thing, how do we know a quadratic? The highest power of x is 2. How do we complete this square? We need to get h and k. I gave you the formula here for h, and I gave you the formula here for k, right? If you all have your different methods of finding computing the square, once again, the same answer, you can stick to it, right? But this is one of the methods using the formula. Then we need to know how to sketch a quadratic. Number 1, what's the minimum? Is minimum if a is more than 0, maximum if a is less than 0. Turning point is always going to be minus hk, and the maximum value is always k. If I ask you for the x value, right here, minus h. How do you find the x-intercept? Solve it. And I showed you the formula yesterday, remember? X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Right? What's the next method? Completing the square, and the next method, factorize. No calculator, right? And the y-intercept is always 0c. All right? And the quadratic generally looks like this. If they ask the axis of symmetry, Just write that. X is equal to minus B and 2A. Of course, work out B and 2A, right? All right, so those are the things that we need to know about quadratics and geometry. Let's take a look at a couple of questions, right? All right. I'm not sure if you'll see 2017 too good. Just write down the important info, right? And we'll do this one together, right? I'm not sure if you're seeing everything. Write down the important info. They gave you two lines, L1 and L2, right? L1, the y-intercept is 0, 1. You're seeing it there? I know you mightn't be able to read off the points in back, right? But L1, you're seeing the y-intercept is 1. Yeah? What's the y-intercept for L2? 6. You're seeing that, right? Yeah? All right. Write that down now. L1, the y-intercept is 0, 1. L2, the x-intercept is 12, 0, and the y-intercept is 0, 6. L1, 0, 1. L2, 12, 0, 6, 0. Right? L1, 0, 1. L2, 12, 0, 0, 6. All right, first thing first, find the gradient of L1. Find the gradient of L1, find the gradient of L2. Okay? If you need, do you have enough information about L1? All you have is what? Yeah, we only have 1.01. So look at the graph and read off one more. 2.5. Yeah, use 2.5 now. Right? Use 2.5 for L1. Use 2.5 for L1. And then try the first part. Right? So find gradient for L1 first. And then find gradient for L2. Right? Right, remember we are using what? 0, 1. Yeah, 0, 1 and 2.5. I forget. Yeah, 0, 1 and 2.5. So we're using 0, 1 and we're using 2.5. So that'll be 5 minus 1, 2 minus 0. I got the gradient to be 2. All together? Right? Find the gradient now for L2. Right? Use the points you have. Finish? Finish? Right? Use the points you have on L2, right? You have 12, 0, and 0, 6, I think. Find the gradient. And you should get how much? How much you got? Minus a half. Nice. Now go ahead, find the equation of L1. It should be real easy. How you find the equation again? Y is equal to what? Mx plus C. What's the gradient for L1? 2. What's the y-intercept for L1? 1. So you don't mind to work this out. Everything right there. Y'all see that? The y-intercept right there on the graph. And the gradient, we know it already. Watch it here. The y-intercept is 1, right? Y'all see that? The y-intercept is 1. Right. What's the relationship between L1 and L2? Look at the gradients. They are perpendicular, negative reciprocal of each other, right? Y'all see that? Right? They are negative reciprocals of each other. Look at L1, look at L2. Negative reciprocals. Okay? So that's how you use 6 marks, right? Let's go again. Try number 4, Jan 2017. See that? Yolanda, see that? What does perpendicular bisector mean? Perpendicular means at 90, right? What does bisector mean? It goes through the middle, right? So that part 3, the one, the line perpendicular to PQ, passing through the midpoint, right? Go ahead, I'll work it out just now. Well, try that in. right, let's see on this one. Can I use the board? Switch over. All right, so gradient is equal to 7 minus 1 all over 2 minus 6. So I got 8 over minus 4, which is minus 2. Anybody got that? Yeah? Then they want the coordinates at the midpoint. So to get the midpoint, you add up the 2x values divided by 2, add up the 2y values divided by 2. Right? So that's 8 over 2, which is 4, 6 over 2, which is 3. That's okay? 4, 3. So that? Keep in see for people. Right? Next, perpendicular bisector. Perpendicular bisector means it's passing through here, but the gradient is what? What's the negative reciprocal of minus 2 on 1? Aha, very good. Right? So we're going to use now, we found the gradient. Which point we using? 6 minus 1, 2, 7 or 4, 3? 4, 3. So we're using the point 4, 3. Right? So we're going to use C as y minus mx. Y is equal to 3. Gradient is a half. X is 4. Half of 4 is 2. So I got y instead to be C. To be 1. All I get that? C is 1. Yeah? So the answer is y is equal to mx plus 1. If you want to make it look nice, you can multiply it out by 2. All right, let's go again. I want to do this one here, but I don't know if I can see it. All right, let's try this last one here. This is 2014, it's a little tricky, right? Look at this here. None of these lines are labeled. None of them are labeled. You just see in line 1, line 2, line 3. You have to use what you learned from about gradients and y-intercept something to figure out which line is which, right? So we think about it and write down what is line 1, what is line 2, what is line 3. Okay? So in your book, write down which equation you think is line 1, which equation you think is line 2, and which equation you think is line 3. Think about it. One of them, line 1, obvious. Line 2, you should see it. And then, well, line 3 might be the hardest for those who don't remember that rule. So write down the 3 lines and write down the corresponding equations. Online, are you okay? Amrita? Devana? All right. So let's check out line 1. What is the y-intercept of line 1? Look at the line. What's the y-intercept? 2. Are you okay with that? Nice. So which one of them has a y-intercept of 2? Y is equal to what? X plus 2. Nice. Y is equal to x plus 2. Okay with that? Line 2. What's the y-intercept of line 2? What's the y-intercept for line 2? 0, right? So which one there is that? Y equal to 2 or y equal to x? Y equal to x has no y-intercept. And then, for those who remember, a horizontal line is always y is equal to the point it passing through. Okay? What's a vertical line? X is equal to the point it passing through. So for example, if I draw a vertical line here, that equation is x is equal to 2. You okay with that? All right. Copy that down if you didn't get it right. Right, they have some more things. Show that the gradient of line 2 is 1. That is easy, right? Show that the gradient of line 2 is what? So y is equal to x, so therefore the gradient here is what? Gradient is 1. Okay? We didn't do shading the regions, right? So forget this for now. We didn't do inequalities as yet. We're coming on to that shortly. Right, but look at part 3. Write the equation of the straight line which is perpendicular to line 1 and passes through the origin. So here's what they want, right? Sorry. They want the equation passing through the origin that's perpendicular to line 1. Remember, line 1 was x plus 2. Right. Quick question. This new line, what's the y-intercept? The y-intercept is, and the gradient is what? It's perpendicular. -1, right? Flip over 1 and change the sign. So, what would the answer be? Y is equal to minus x plus 0. Okay? Because the y-intercept is 0. You all okay with that? Let's change the coordinate geometry and then we're going to do some graphs. Let's change the quadratics I meant, sorry. Right, we're just going to do 1 or 2 of these because it's just fair to use the formula. So let's start here, June 2013. First question, here's what they ask. They ask you to write the quadratic 3x squared minus 12x plus 8 in that form, right? I want to work with you a little bit to make sure you go a little fast, right? A is how much? A is just the value alone, so 3. Right? Coefficients alone means the value and the sign. B is how much? Minus 12, value and the sign. And C is how much? Positive 8. Everybody okay with that? Yeah? Now go back to the formulas, find H and find K. Right? Use the formula that from the summary. Find H and K, find the y-intercept and the minimum point. And we'll sketch it. Hurry up. right? Work out H and K, and then let's do a quick sketch. The question didn't really ask, but you'll need to know, is this min or max? Because A is what? More than 0. So it's a minimum, right, Faith? Right, remember, H is what? B over 2A. Right, H is B over 2A, B is minus 12, and A is 3. So I got minus 2 for H. Yeah? And K is what? K is C minus AH squared. Please remember, when you're using this formula, you square the H first, then multiply it by A, right? So C is 8, A is 3, and H is minus 2. So when you square minus 2, you will get 4. 4 by 3 is 12. 8 minus 12 is minus 4. Right? So we know H and K now. So the answer will look like this. Right? The answer will look like A is 3. X is X. H is minus 2 squared plus K. K is minus 4. So your answer for the first part looks like that. What about the y-intercept? How do we find the y-intercept? The y-intercept is always what? What's the y-intercept? Look at the summary quick and tell me what the y-intercept is. The y-intercept is always 0, C. And C in this case is 8. All right, so it's 0, 8. What about the coordinates at the minimum point? What's the coordinates at the minimum point, Bradley? Always what? Minus H and K. Very good. So that'll be what? Positive 2, minus 4. Right? So once you remember the formulas, it should be all right. Right, sir? You okay with that? But you have to remember the formulas, right? How to find H, how to find K. Okay? But they want a little sketch, right? They want a little sketch. So I was creating a little quick sketch here for you. It's a minimum. Y-intercept is 8, so it might be somewhere here. Right? So it might look something like that. Hold on, Here is 8, and they want the minimum point, 2 minus 4. That's it. And again, your 4 marks, right? All you have to show them is your y-intercept and that minimum point. That's okay? But in order to do the question, you need to learn those formulas, right? Let's do our next one. Any questions? I'll write it down. Let's do the next one. Somebody writes it, no? (2015), the one on top. Minimum is the most popular, but sometimes you might see a maximum. Try this one here. Right, these are the same formulas about this one out. Huh? All. Do all, right? Everything is seen that you're doing. I could say a summary, use the formula. It's easy math on the CSEC section. Right, remember I do a small sketch, huh? Oh, you have 2 minutes again. Everything good things. That's something else. All right, let's see how it went. First thing, we had to get H and K, right? So A is equal to 3, B is equal to 6, and C is equal to -2. H is equal to B over 2 by 3. So I got 1. Yeah? And K is equal to C minus A by H squared. So that's -2 minus 3 is -5. Yeah? You all got -5? So that's -5. So the answer here is 3 by x plus 1 squared minus 5. That wouldn't be. Remember, it's -2 minus 3 by 1 squared. 1 squared is 1. 1 by -3 is -3. So -2 minus 3 is -5. Right? 1 squared is 1. 1 by -3 is -3 still. So it will be -2 minus 3. Remember, you cannot square in the A, right? All right, so hence or otherwise, state the minimum value. The minimum value is always what? The minimum value is always K, so you're right, -5. State the equation of the axis of symmetry of the function. Axis of symmetry, if you look at the rule, is always x is equal to -h. So that is x is equal to -1. Everybody okay with that? Well, what is the intercept for the y? We know it's always 0, c. Everybody okay with that? And what's the minimum point? The minimum point is -h k. Right? All you have to do now is just show it on a graph. It's a minimum, so it looks like that. Y-intercept -2, minimum point. Oh, sorry. What's wrong with my graph? It's on the wrong side, right? It's on the wrong side. Right? Because both the x value and the y value negative. So it's -1, -5, and this value here, -2. And you're good to go? All right? Copy it down. Let's go to transformations now. Right? So you'll need a graph paper to plot and then do the quick transformation. Actually, wait, before we do transformations, let's take a look at the code. I want to show you how to do some quick construction real fast, right? You don't need to know all. The trick is really bisection. Okay? You need to remember how to bisect. All right, so you'll need a compass. No protractor. All right, so I'll just use this. Like during the crash course, most times I don't get to do questions like area and volume and thing, right? So that 1, 2 things I don't really get to do. If we get in trouble, we could always practice that later on, right? Area and volume and cross-sectional area and things. All right. So there's just one thing I want to do. I just not showing here. Right? Right, online. Somebody can just go on YouTube and see if one of the people behind. So somebody said yesterday the board wasn't showing on YouTube. So when you're looking back at the video, you wouldn't see anything. Huh? You're not showing? Right now it's not showing? Does the host there? So you're just hearing me on the blank. All right, online, but online, you're seeing me, right? All right, too bad for the YouTube, right? Pinned on the host. But pinned here as well. All right, I will probably not use the board anymore, right? Anyway, I just want to bisect and then we'll go back, right? So, firstly, let's draw a line 8 centimeters long, right? On that line, I want to show you how to cut the line in half, right? How do we bisect that line? So, what you do, remember, you have a compass, right? So the compass has a part with a pencil. Online, you'll seen me, right? On the whiteboard. Yeah? Yeah, do it in your notebook. Right? You have your pencil, and your pencil is connected to the next side with the needle, right? Right. This distance here is what we call your radius. So when I say open your radius, that's what I'm talking about, right? That's okay? So use your compass. Use your compass. Place the pin here at the point A and open the radius to more than half. Open the radius to more than half. All right? Again, place the compass, place the pointer here, place the pencil here, more than half. Right? Open the arc more than half. And I want you to draw an arc on top here and an arc underneath here. Make sure the radius is more than half. All right? Then place a pointer here at B. Place a pointer here at P. And do the same thing, exact radius. Don't change the radius. Place the pointer here and then do your arc. Where the arcs meet, right? Where both arcs meet, draw a line connecting them. That line should split this in two at 90 degrees. Everybody get that? That's the most important thing you need to know in construction, well, for the latter years, right? The earlier years, they should make it constructing. So for the latter years, I really want, this is the main thing I'll be able to do, how to bisect a line. Okay? So to bisect a line, these are the arcs that you have to show. And make sure the radius is more than half. It doesn't matter where. You'll get the same answer. All okay with that? Right? I want to show you one more bisection. How to bisect 90 degrees. Right? How to bisect 90 degrees. Everybody okay with this? Everybody can handle this? How you bisect 90 now? Real simple. Put the pointer here and draw arc. Right? Draw arc. Doesn't really matter where. Right? But draw arc. Make sure the arc fit between the two lines. Right? Where the arc meets the line, let's call that C, and let's call that D. do not change the radius, right? So whatever radius you choose here, leave it just like that. Right? Place the pointer here and draw your arc to meet the line at C and meet the line at D. Anybody confused? Yeah? Who got lost? You got lost? You get it bisecting? Right, so place the pointer here and just draw arc to meet the lines at C and D. Pardon me? Close it in, yeah, close it in. Right, how to meet C and D, of course, it's to close it. Right, now, don't change the radius. Whatever radius you use here, leave it like that. Place the pointer at D, draw arc. Place the pointer at C, draw the arc. Where they meet, draw it down to the point E. This angle here should be 45 degrees. Right, listen again. Pointer at D, draw your arc. Pointer at C, draw your arc. Right, but you need this arc first, huh? You need the arc CD first. Pointer at C, draw your arc. Pointer at D, draw your arc. Let's check what YouTube was. Check and see in a little while again, right? I'll just switch back the host. I pin it down. It had reached 10,000. 2 months. I had recorded 2 months. But 10 minutes or 5 minutes, it could change, right? Right, so, all okay with this? You draw your arc, keep the radius at D, arc at C, arc. Okay? That's it. That's all I want you to do. I'm not going to teach you 60 and 90 and thing, right? That'll really come. You can look at one of the old videos if you want to learn 60 and 50 and 30 and things. Nice. From this, let's go to transformations now. The most important construction that you will use is the one to bisect a 90, right? Sorry, bisect a line. Bisect 180. Okay? All right, let us take a look at construction. Transformation, sorry. And come back. Right, anybody remember the 4 main transformations? See if you remember the 4 main transformations. Right, the 4 main transformations are what? Rotation, reflection, translation, and enlargement. Right? Enlargement will make the image bigger or smaller. Translation is a what? A slide. Right. Just showing. Right? Reflection will be a mirror image, right? Beyond some line. And a rotation is a what? Is a movement, right? Right? It's a movement, right? It is not really a slide, you can say. Right? Because you actually rotate in the shape as well. All right, so let's start with the easiest one, translation. So translation, you move left, right, up or down, right? What controls left or right? The X value, right? The X value controls left or right. What controls up or down? The Y value, okay? So here's an example, a translation of 5 minus 4. What does that translation say? It moving to the right 5 and down 4. That's okay? Right, but you don't want to have to always check 5 to the right and 4 down, right? There must be an easier way. So here what you do. Plus the take the point, let's pretend this is, we don't have to pretend, right? Just so by. Right. Let's say this is a point. Let's call that point 5 minus 2. How do I perform a translation on that point, comma? Right? How do I perform a translation on that point? Add it to 5 minus 4. 5 and 5 is 10. And minus 2 minus 4 is? Oh, what I do wrong there? Right? I write the point upside down. The Y value is 5 and the X value is minus 2. Okay? So that's the way you perform a translation. Minus 2 plus 5, that's 3. 5 plus minus 4, that's 1. So you plot 3, 1. That's okay? That's the way you do a translation. Everybody okay with that? Yeah? Harmony? How you do the reverse harmony? Suppose I told you how many, I have the point minus 2, 5, and I have the point 3, 1. What would have been its translation? What you'll do? Anybody remember? Anybody can help her? Minus, right? Do the reverse, right? Do the reverse, right? So it will be 3, 1 minus 2, 5. Okay, and then you will get the translation, right? Just to the reverse. Carisha, okay there? So basically, the main thing for translation is the translation vector, right? Right? Next, reflection. I don't have all here, right? But we'll talk through them. A reflection in the x-axis. Here's an example. What is change? Suppose you have to reflect the point minus 2, 1 in the x-axis. It becomes what? Anybody remember? All right. When you reflect in the x-axis, it becomes same x value and the y value changes sign. That's okay? When you reflect in the x-axis, write it down if you never heard it before. When you reflect in the x value stays the same and the y value changes sign. Write it down. Right? It's not in the summary. Nah. Okay, just say please. Y value changes sign, x value stays the same. Reflection in the x-axis. X value stays the same, y value changes sign. Y value changes sign. What about the x-axis? If you reflect in the y-axis. If you reflect in the y-axis, what will happen? The x value will change sign. What about the line x equal to y? What has happened there? Anybody remember? X equal to y, here's what's happened. If you have xy, it will switch now to yx. So the x and y will switch positions. X become y and y become x. What is something here important whenever you're doing a reflection? Something very important. You have to make sure what? Right? Stay the same size, and what else? One more thing. So they must stay the same size. And just one more. What's the one more thing? Huh? Well, the angles in the triangle, yes, stay the same, but something else, something very important. Okay, they're always equidistant, write it down, always equidistant from the mirror line. They are always equidistant from the mirror line. Okay, write it down. Bradley, write it down. Equidistant from the mirror line. So suppose I don't give you a mirror line now. How are we going to figure it out? Suppose I don't give you a mirror line, Faith. How are we going to figure out the mirror line, Faith? Huh? Come on, Faith, have faith that you'll figure it out. Right? Real simple earlier. Connect here and here with a straight line. Right? Connect it with a straight line and then bisect the line. If you bisect the line, you'll get the mirror line. Right? That's the reason I showed you this earlier. Okay? So write it down. To get the mirror line, connect the point and image. To get the mirror line, I'll have to add this. After adding this thing into the summary. Find it strange, I don't have it there. Right? Connect the point and its image. Connect the point and its image and then bisect it. That'll give it a mirror line. Connect the point and its image and bisect it. Okay, nice. Let's go through. So basically, to identify a reflection, we need a mirror line. That's okay? A rotation now, what do we need? For a rotation, we need center of rotation, angle of rotation, and direction. Okay? So for example here, A is rotated to B. Are you okay with that? What direction? Clockwise or anti-clockwise? Clockwise. How do you figure out the angle? Right? To figure out the angle, connect 2 points that you rotate. That's okay? Oh, sorry, I assume I know the I assume that we know the rotation. The center. Here what you do. Yes, connect the points that rotate with a line and bisect it. Connect the next two. Connect the next two. Bisect it. Where those two lines meet will be a rotation. Okay? So you're connecting again, bisecting, but you're doing it twice. The mirror line, you just do it once. Right? For rotation, you do it twice. And they will meet at the they will meet at the center rotation. So in our example here, we have the center 0, 0, 90 degrees, and the direction clockwise. Just to remind you how to rotate, draw a line from the point to the center rotation, measure off the angle, and then draw a line of equal length, making that angle. Where it meets, that will be your center. Sorry, that will be an image. That's okay? Watch again. Watch again. Right? Suppose I wanted to rotate here. Draw a line from there to the center. Right? Measure 90 degrees and then draw a line of equal length. And it will meet right there. Right? If the point is -25, your answer should be some variation of -25 Malachi. All right? It should be some variation. +25, 52, something like that, right? If you get 4.9, some wrong. If you get 4.5, 7.3, some wrong. Right? Probably measure wrong, right? And last one. So please remember the three things for rotation: center, angle, direction. Last thing, enlargements. To get the enlargement, we need the center of enlargement and we need the scale factor. So here we have the center of enlargement of -45. That's right here. And a scale factor of 2. How do you do an enlargement? Real simple. Watch this here. Right? You have to remember your steps, right? First thing first, plot the point for the center of enlargement. If it's a positive scale factor, it will be behind the object. If it's a negative scale factor, where will it be? On the opposite side. Negative is here, positive is here. Everybody okay with that? How do we do the enlargement now? Center is here. Measure the length from the center to point. And then, if the scale factor is 2, double that length. So draw a line from the center, double length. And you will reach where the image will be. Right? Watch it again. Draw a line from here to here and double the length. And that will take you to your image. Everybody okay with that? Quick question. Suppose they don't give us center. What to do? Suppose they don't give us the scale factor. What you'll do? Bradley? Ask you already? Ask you a question already? All right. Richard, I didn't ask you one as yet. Well, again, sleepy, so I started to ask all the questions now. Yeah, Richard, what do you think? How you'll get the scale factor? Look at that question. I did not give you the scale factor. How are you going to get it? Measure the length of this line and measure the length of this and divide it. Now you're going to say, yeah. I read your mind. Right? And divide it and you'll get your scale factor. How you will end up with rotation. How you will get the center of enlargement. Jacob. The answer right there. Yeah. How you'll get it? How? Yeah. How? Yeah. How? Huh? Pardon me, you just look and find. Very good. Very good. So you would draw a line connecting the image and the object, the image and the original. Draw a line connecting it, and where they meet, that'll be your center. Right, Kayla? Keely, are you okay there? All right. Let's go to graph paper time. Graph papers time. Graph paper time. All right. I want you to plot it, but you know how long it might take to plot that? What's the fastest so we could do this way? All right, let's do this one together. We'll do the first one together, right? We'll do the first one together. Complete the transformation. What does this look like? Let's start to narrow out some, right? Let's start to narrow it down. Is it enlargement? No. Is it translation? It's not a slide, right? Does it look like a reflection? So therefore it boils down to being a rotation, right? Okay. What do we need? What do we need to describe rotation? Number one, the direction, clockwise or anti-clockwise. Look at that example there. A, B, C to A prime, B prime, C prime. They went this way. So the answer is clockwise. All okay? Yeah? What about, how do we get the center rotation? What you do? Connect what? Connect B and P prime and bisect it. Connect C and C prime and bisect it. Y'all see that? So where those two lines meet in? At 0, 0. Everybody okay with that? Y'all seeing that? Malachi said it making any sense. Let me just do it over. Right? Connect B with P prime and bisect it just like this. Connect C and C prime. Bisect it just like that. See where they meet in? They meet in at what? 0, 0. Right? And what's the angle between them? What's the angle between them? 90. Okay? The angle between them is 90. Anybody could tell me how to do that translation? What to do? How do we translate 4 minus 5? What does it say? 4 what? 4 to the right. And minus 5 means? Right. Minus 5 means 5 down, right? Minus 5 means 5 down. Okay. So how do I actually do that? How do I actually do that? All I have to do is take this point here and add it to 5 minus 4. Sorry, it was 4 minus 5. Everybody okay with that? Are you sure? All right. So this next one here, I'm going to make you do it, right? Hold on, eh? I'm gonna just get a hard one. Sorry, long one. All right, yeah. Let's do this one here. 1 to 1. 1 centimeter to 1. And plot those two triangles. Quick, quick, quick. 1 centimeter to 1. Right? Split the graph in 4 and plot those two triangles somewhere. Quick, quick, quick. Oh yeah, split it in 4. Just one we'll need to see because I think linear programming, right? inside as well. To the graph in 4, right? Oh yeah, 1 to 1. So pencil, please. 1 centimeter is 1, and for the accuracy, yeah. We'll make up points on plus it. 1 centimeter is 1 on plus. One centimeter is 1, right? In case you're not seeing the first triangle, those are the points, right? Right? Those are the points of the first triangle, ABC. And then these are the points of the second triangle. A prime, B prime, label it properly, right? All right, good. Everybody have them? Everybody have ABC, A prime, B prime, C prime, right? Write down the coordinates of first part is to write down coordinates, right? Write down the coordinates A prime, B prime, for B, A, B, C, and the vertices of A prime, B prime. That should be easy, right? Once you plot it, you should be able to write it down. For example, A prime is 2 minus 3. Everybody okay with that? Anybody have issues with that? We're just reading those things off, right? So the first thing I want you to do now is to describe fully the transformation that maps triangle ABC to A prime, B prime, C prime. Try it on your own. Use your diagram and try to describe it. Again, rule them out. Is it an enlargement? Is it a translation? Is it a reflection? If not, you know what it is. Okay? Rule them out and describe it fully, please. By the way, you cannot assume that the center is 0, 0. You have to show them it on your diagram. Okay? Right? What you all create is a what? A rotation, right? Nice. It's a rotation. Right? Tomorrow you need graph paper. We could probably squeeze in some stats. Sometimes it'll take a little while to plot, but I want you to plot cumulative frequency and thing, right? That's come a lot. So we start the programming. I say remember tomorrow we're trying to 8:30, right? Hmm? A little bit. Right. Open to the best. All right. So let's see what you got. So ABC to A prime, B prime, C prime is what? Clockwise or anti-clockwise? Nice. Next, we have to show them how we got, right? We have to show them how we got the center, right? Reggie, you show them? I show them? Yeah. So you connect A and A prime, right? And you bisect it. Oh, shucks. And you bisect it, right? Connect C and C prime and you bisect it, right? And you should get 0, 0. Please practice it. Make sure you get 0, 0. I could be wrong, but looking right. So I don't feel that wrong. So the center is 0, 0. You have to show them those lines, huh? You can't just assume it's 0, 0. Okay, looking nice, right? Show them. Show them. Reggie, you show them? Did you show them? Right? Connect your A and A prime and bisect it, right? You all getting it? It is at 0, 0, right? Nice. Connect, make sure and try it all, yeah? You won't magically be able to do this for exam, right? You can't do it, Reggie. You connect A and A prime. Connect A and A prime. Anybody can't do it? You're doing this here. You connect it A and A prime. You're opening your arc more than half. Get this one, opposite side, get this one. Where they meet, connect them. Right? You are doing this here. You do it, Yolanda? Sure, I'll come to watch. You can do it. Oh. Right, but you can't do it for one line. You have to do BP prime as well. Right? And see where they meet. Right. And please don't try to well, I don't know how to do it online now, but normally there's look for holes in the book. Some people like to draw the line and then magically put on the arc. Right? But these look pretty holes in the arc. Right, bisected class, please. That's not bisected. All right, it'll take too long. Right, so that is when you bisect it, you'll get 0, 0, and when you finish, you draw a line here to here and here to here and measure the angle. Right? Draw A to the center to A prime and measure the angle. Yeah, it will look, but that's it there. That's it there. A to A prime bisected. See, anyone you want, it don't matter. C to C prime, B to B prime. You all get it right? At 0, 0, right? Shana, you got it? Next one, next part, same graph. Draw the line x equal to 1 and then draw the image. Draw the line x equal to 1. Where is that line? I'll pick on somebody, yeah? Where is that line, Bradley? Pick on Bradley already. Jamie, I don't see her. Who's I'm see her? I'm here, Jamie. Where is that line x equal to 1? Where? Vertical line or horizontal line? Vertical line passing through what? X is 1, right? Good. How do we get the reflection now? How do we get the reflection? Pick on somebody else. Ricardo. How we getting the reflection for C? What you have to do? Look back at the rules for reflection. You have to make sure 2 things. Can you write it down? Yes, Sama, boy. You want for the whole class there, boy. Yeah. I would like to reflect ABC. Right? Reflect C for me. But you have to make sure. Same. Same distance, right? So how far will C double prime be from that line? Sum in terms of blocks. 2 blocks. So C double prime is right here. Y'all seeing that? In Ricardo? Where would A double prime be? Where would A double prime be? Two blocks away again, right? 1, 2, 2 blocks away. That's all. And where will B be? B will be? Well, okay, 3 blocks away from A, double prime. Okay, all right. That could work. And it connect it up. So it should be the same size, right? Is it the same size? Yes? Are you laughing at Soraya? Now for the last part. I think the last part is to state one geometrical relationship among A, B, C, A prime, B prime. What? One geometry. Oh, I thought I was going A prime here. What is one geometric relationship between all of them? All the same size. That's all. All the same area, right? All of them are the same size. Okay, all are the same size. All right, so that's the way to do transformation. And we can squeeze in one more, boy. Yeah, I feel so. We didn't do an enlargement. Yeah. All right, here's what. This enlargement, we can do it right here. Right here. Right, scale factor. We're doing it together. I'll ask people if you get it right. You and your row can leave. I should do this in convent. Nobody should get to go. Right, number 1, scale factor. No, what is the scale? Oh, by the way, what is this? Triangle. Very good. You will say a little bit. An enlargement, right? Right. No. That who would answer the questions, right? Right. What is the scale factor? Huh? What's the scale factor? Anybody? And your row could finish. Scale factor is 2. So you're taking this length and dividing it by this length, right? Q prime, R prime divided by QR. So that's 1, 2, 3, 4 over 2. All right. Next. Is the scale factor positive or negative? What you all think? Oh, positive. Negative. Which one? In between? I learned the marks are ruled on the back. Atili and Kayla. This is positive or negative? Anybody in you can answer? Positive or negative? It's negative. They're on opposite sides of the center. Okay? They're on opposite sides. And all right. Okay, all right. We'll wrap up there. Right, next day we still have plenty more things to do. Next day we have to do stats and linear programming and a few other craft things. So work with your graphs.